Alright students, welcome to yet another video in my lesson 1 for my fluid mechanics course. Starting from this video, I'm going to do some things a little bit differently. Because dimensions and units covers a variety of things, some of which you already know and some of which you may not have seen before, I will divide this section into several subsections. Each video will cover just a small topic of that subsection. That being said, in this video we're going to look at physical quantities. We're going to describe them, we're going to quantify them, and we may look at maybe one or two examples. Now, physical quantities are those quantities that we use to describe the world around us. We can quantify them using dimensions. Dimensions include things like length, time, area, volume, force. Now, because there are so many dimensions, for this course we are going to simplify them into 5 fundamental dimensions. They are length, mass, time, temperature, and plane angle. Now note that those are the 5 fundamental dimensions that we've chosen for this course. Other literature and other courses may choose force as a fundamental dimension instead of mass. And also note that in just the general engineering fields, there are more than 5 fundamental dimensions. Typically, you may see a lot of literature showing 9 fundamental dimensions. However, for this entry-level fluid mechanics class, we will focus on those 5 dimensions. So length, mass, time, temperature, and plane angle. If you've made it this far in your engineering career, then you probably already know how to use all of these dimensions. But just as a quick review, let's look at a quick example. What are the fundamental dimensions of density? Now, if you've taken an introductory physics course, you can already tell me that density equals mass over volume, therefore the dimensions of density should be mass over volumes. And while that is not technically incorrect, when we talk about fundamental dimensions, we want to focus on the 5 that we've selected for this course: length, mass, time, temperature, and plane angle. If we know that the density is equal to mass over volume, and we take the dimensions of density, that is equal to taking the dimensions of our mass variable and dimensions of our volume variable. The dimensions of mass are, well, mass. And that's actually about as fundamental as they can be. So, mass itself is a fundamental dimension. However, volume can be broken down into 3 length dimensions. So we break down volume as length cubed. Therefore, the fundamental dimensions of density are mass over length cubed. For this example, while this is not exactly a rule, we can see density as our physical quantity. And we can see mass and volume as the dimensions of said quantity. Now, while mass itself is already a fundamental dimension, volume isn't. Therefore, we can see mass over length cubed as the fundamental dimensions of density. This exercise of breaking down quantities into their fundamental dimensions will be useful in a future lesson called dimensional analysis. But for now, try to get familiarized with the basic fluid properties and their fundamental dimensions.